G'day everybody, welcome to Discovering Ultibo. We're doing episode 5 today, and we're going to do something a little different. We're going to show how to use one of these little 2-line LCD displays. This is the Adafruit 16x2 pie plate LCD, but you can get them all over the place. I'm going to show what Ultibo can do with one of these. So we've just created a little project. We'll plug him in there and fire him up, and he just comes up and says hello LCD 16x2, and then he scrolls a couple of lines on messages, on one on each line in opposite directions. Pretty easy to do using the console functions in Ultibo, and so we're just going to go and have a look at the code of how you do that. So let's switch over to the computer and bring up Lazarus, and we'll see what it takes to create that project. So here we have Lazarus open. Here's the project. It's a standard Raspberry Pi 2 project. We've added a couple of units for the console and the AF16x2 LCD unit, which is actually the driver for this particular device. Now, there's a lot of very similar devices. You may need to modify slightly if you're using a different one, but they're quite similar to each other. So if we go down to the bottom to the begin-end section, we'll just have a look what we're doing. There's some functions in the AF16x2 LCD unit to turn on the backlight and set backlight color. You can play with them yourself. So we go backlight on, backlight color. It's obviously red, green and blue is the colors, so you can try all sorts of combinations yourself. And then we do our normal console window create, and if we have a look at console window create, requires a console device, but normally we call console device get default, don't we, in all of our examples. This time we're calling console device find by description, and that's a little different. We're actually going to get the console device Adafruit 16x2 LCD, which has been installed by the Adafruit 16x2 LCD driver. Rather than getting the default device, we get a different console device that's created by this particular driver. We pass it to console window create and ask it to create at the console position full screen. That's the entire screen all in one, no other windows. We get back our window handle, and like always, we can just go console window right line and pass some text to it and write that on the screen. It's as simple as that. So the driver's actually hooked itself into the console functions in Ultibo, so you can use it with just normal console functions. We sleep for a bit, and then we call console window clear by passing the handle, and we clear it. Now, to do our scrolling, we've actually gone and created a couple of threads. Basically, you could do this in all sorts of ways. You could do a single function that scrolls one row backwards and one row forwards, but I thought it'd be fun to create two threads and just have one scroll the top line, one scroll the bottom line. So we've got our normal begin thread function, which you've seen used in other examples, and we're passing two different functions here, first line scroll thread and second line scroll thread, and they're the thread functions that we need to pass to begin thread. So let's go have a look at what they do, and they don't do much either. So here's our first line scroll thread. All it does is call rotate text with our window handle and the message scrolling the Adafruit 16x2 LCD with Ultibo. We pass a line number and then a value false, which says whether we want to scroll right to left or left to right in this case. And our second line scroll thread, all it does is call rotate text again with the Ultibo homepage URL, line number 2, and this time true. So we're going to scroll left to right instead of right to left. So now let's have a look. The heart of all of this is the rotate text function, and this is very generic. You could actually use it to scroll text on any one of the console windows in Ultibo, and it should work quite normally without any change. I don't think I've done anything that's terribly specific to the 2-line LCD. So it starts off with some simple checks. Is the line length valid? Is the text length valid? We add a couple of spaces on the end of our text so that our tail doesn't catch up with our head. Our head catch up with our tail, whichever way you want to put it. When we're doing the rotate around, so we've got a couple of spaces in between. We check the length of the text buffer to make sure it's valid. We get the width of the console to find out how wide our screen is, so that should work with any width console. We check the height of the console, and then we call console window write ex, so the extended version of console window write. Let's just have a look at the parameters required by that. Obviously a handle. It needs some text. So what we do is we copy, using the normal copy function, from our buffer all of the text that will fit in the width of the window. So remember, we don't want it to word wrap or scroll at this point, so we just want to fill the line with text. So we copy from our buffer the amount of text that will fit in the window as it stands. We start from x of 1, so that's the first column, and the line that was passed to us. Now, the console window functions always require forecolor and back color. This is a black and white LCD, so it doesn't care, but we still have to pass them to the function. So we can call the existing functions console window get forecolor, console window get back color to ask what they are, even though they won't ever be used. Now, the other variation of that, all it does is it copies width -1, so it leaves out the very last character, and that's just to prevent the screen scrolling on the last line. So we went if line equals console window get height, so the last line, then we leave out the very last bottom right character so that we don't scroll the screen accidentally. We sleep for a bit, and then we decide which way we're going. Are we going right or left? So where is our starting point? Well, if we're going right to left, then our starting point will be the width of our screen +1. If we're going left to right, then it will be the last character of our buffer, of our string that was passed. So we want to scroll the last character in first. We go into a loop, and we do two different things depending on whether we're going left or right. So we call console window scroll left if we're going right to left. It needs a handle. It needs to know which row, so we were past the line number, the first line or the second line. It needs to know the column. In this case, we want to scroll the last column, and we want to scroll one line, one character to the left. So the whole of one line, one character to the left. We then call console window right char ex. We pass it the handle and the character, which is our buffer, the starting position of our buffer. Remember, we calculated the start above, whether we're starting one past the width or whether we're starting right at the end. We want the width, which is the last character in our console, so the very rightmost character. We want the line, and we want the forecolor and back color. Not needed, but we need them anyway. We increment the start. We check whether we've wrapped past the length. If we have, we go back to the beginning again. We sleep a bit and we go round. So we just go in a loop, scrolling one character left, adding the next character in our buffer. Simple as that. If we're going left to right, we call console window scroll right. This time we pass the handle, the line number, but our column, our starting column, is the first column, not the last column, because we're going left to right. Again, one line, one character, so scroll the whole line, one character to the right. Add the next character in our buffer using console window right char ex. Decrement the start this time rather than incrementing because we're scrolling backwards. Check if we've reached the start of our line. If we have, go back to the end, sleep, and go round again. It's as simple as that. And it's as I say, a very generic function that you could actually use in your own programs to scroll 2 lines of text or 4 lines of text or whatever you might want to choose. So something you can play with later on. So that's as simple as it is. And if we go run, build, it all compiles, and that's what we've got running on our Raspberry Pi. So if we go back to our Raspberry Pi and have a look, it says scrolling the Adafruit LCD 16:2 with Ultibo. Simple as that. Lots of fun. You can try your own messages and play with it as much as you like. So I hope you've enjoyed seeing what we can do with a little 2-line LCD. Come back next time when we do some more with episode 6. Thanks for watching. We'll see you again. Bye.